My name is Rebecca Kim. I am a second-year graduate student in the NYSTA lab at UCSF. Our lab studies the stem cell in the Drosophila ovary. A lot of people in my lab study what's going on in the stem cell to help maintain its stemness and what distinguishes it from its differentiated daughters. My specific project actually has to do with the environment that the stem cell is residing in. The environment that the stem cell is in provides a lot of important signaling molecules to ensure that the stem cell remains a stem cell. So my project actually deals with how these important signaling molecules are transmitted from the cells that make them, the source cells, to the target cells that need them, in this case the stem cell. I'm from Cincinnati originally. I've wanted to be a scientist since I was like 10. My mom was a registered nurse, and my dad taught physics for a while, and then is now teaching science education to people who will eventually become teachers. But I was interested in basic science. I never really considered being a doctor because I wanted to run experiments and I wanted to learn about things. So I started research coming on my senior year of high school, and I did research all through undergrad. And then eventually applied to graduate school and got an interview here at UCSF and decided to move out here. I don't know if I have a typical day. Every day is a little bit different for me, which is one reason I like doing what I do. At least every day I check up on my flies to make sure they're happy. Usually I'm setting up a cross to make experimental flies. Sometimes I'm dissecting flies and staining them for proteins. Some days I'm on the microscope looking at the flies that I dissected and stained. Stem cell research, I feel like, is a pretty hot topic right now, especially in regenerative medicine, because stem cells have the ability to turn into cells with specific jobs. They're of interest for regenerative therapies. So, for example, if somebody has a damaged heart, if way in the future we could take stem cells from that patient and grow tissue, or even, potentially a new heart, they would have the patient's own tissue characteristics, and so their immune system is much less likely to reject it. That, of course, sounds all kind of futuristic, but understanding how stem cells work is a really important step to getting to those sorts of therapies. And specifically the research that I do about how to keep a stem cell happy by understanding the environment in which it resides is also an important component of that. I recently undertook learning about new techniques, and it really helps to have people in the lab who've done it before, because then you could go ask them questions, they could help you troubleshoot things, and that sort of teamwork makes me feel less alone. Like, I have people that I can fall back on and ask questions to, and science can be really rewarding. It can be really tough, and there's a lot of obstacles that everyone has to overcome, but it can be really rewarding, this idea of discovery and contributing to a field and collaborating with people. I'm really inspired by my own mentors who really contributed to my own development as a young scientist, and I would like to pass that along. Say if you really love it and you're really interested in it, go for it, because contributing new scientists to the field, I think that's going to be much greater than my own individual contributions and my own discoveries.